This video is for lesson 4.4, solving for a variable in a linear relation. So what does that mean, solving for a variable in a linear relation? What we're doing is we're solving for y in terms of x. It basically means that we're going to have an equation with two variables, x and y, and we're going to want to isolate for y. We're going to want to isolate for y. And that's going to look like the equation we saw in the previous lesson, 4.3c, where we have y is equal to mx plus b. What we have here is we've isolated for y. We have y in terms of x. So when our x changes, that's going to cause our y to change. And this is called a linear relation. And one of the reasons we call it a linear relation is because when we put this on a graph eventually on a grid, we're going to see that it gives us a straight line, a nice straight line. And the line can vary. It can be steep or less steep depending on what your m is. But the main point is that it's called a linear relation, and we've isolated y, and as we change x, our y is going to change as well. So here we have an example of having isolated y, a linear relation. We have y is equal to 2x plus 5. So if you put different x values in here, you're going to get different y values. But the main point is that right now we have y expressed in terms should be an r there, of x. And that's the idea behind solving for y. So we're going to do an example together where we have to solve for y. Right now we have an equation here, negative 2x minus 3y is equal to 12. And so I want to make it so that I isolate y, that I get y in terms of x in the format of y is equal to mx plus b. So what I do is I have to get rid of everything that's on the side where the y is. That includes my negative 2x, it includes my negative 3, and we're going to do that much the same way we did inverse operations from previous lessons. So first I'll get rid of the negative 2x. Remember we're doing BEDMAS backwards here. So negative 2x plus 2x, because that's how you get rid of the negative 2x, minus 3y is equal to 12. Don't forget that since we did plus 2x on the left side, we have to do plus 2x on the right side as well. Negative 2x plus 2x is 0, so is 0x, so that's gone. So what we're left with is negative 3y is equal to 12 plus 2x. And so now what we can do is we need to get rid of that negative 3 in front of the y. The negative 3 is multiplying the y. So to inverse the multiplication, to the inverse of that multiplication, we do a division. So we divide both sides by negative 3, like this. And what I get is, let's continue that here, every term here has to be divided by negative 3, so negative 3 over here, negative 3 over here. The negative 3's cancel out, so I get y is equal to 12 divided by negative 3 is negative 4, and then plus 2 over negative 3, which is really like saying plus negative 2x over 3. If you clean that up, it looks something more like this. Y is equal to negative 4. When you have plus minus, that becomes minus 2x over 3. Now, usually when we write this equation, we want to make sure our mx value comes first. Remember, it's in the form of y is equal to mx plus b. So I'm just going to rewrite this with this term first, and then this term after. So y is equal to negative 2 over 3x over here minus 4. And that is our equation. This over here represents our b, and this over here represents our m. The m is negative 2/3, and the b is negative 4. In the example that we had up here, the m is 2, and the b is 5. So if you have an equation like this and we ask you to solve for y in terms of x, it just really means isolate for y. So now we'll do an application problem together. So we have Ariana, she has $42.50 in quarters. We want to write a linear relation, or linear equation, expressing the total number of money in terms of the number of quarters. Solve the equation. So there's two parts to the question. There's writing down an equation, and then there's solving that equation as well. So what we're going to do is we're going to define our variables first. So we're going to let y represent the total amount of money, and that'll be in dollars. And we're going to let x represent the number of quarters. And so we're writing a linear relation, meaning we want to write an equation that has y expressed in terms of x. So we're going to write that y is equal to a quarter. So a quarter is 0.25. So 0.25, that's 25 cents. Multiplied by x, which is our number of quarters. And so now that we have this, we're able to figure out how many quarters Ariana has if she has $42.50. Remember that y is our total amount of money. So this, in this case, represents our y. The y will be different depending on how many quarters you have, but in this case we have $42.50. And so what the question is asking is, how many quarters do you have if you have $42.50? So to finish this problem, we're now going to, this is our equation here, we have that. Now we're going to let y equal 42.50. And then we're going to substitute y into our equation. So that's going to be 42.50 is equal to 0.25x. And we want to solve for x. We want to find how many quarters Ariana has. So we really just need to do the inverse operation here. We need to divide by 0.25 on both sides. I did that on the right side. I'll also do it on the left side. The 0.25 cancels out here because that's just 1. So we do 42.50 divided by 0.25. And we get x is equal to 170. And then you can write a therefore statement. So therefore, there are 170 quarters. You would write a nice sentence. There are 170 quarters. Or Ariana has 170 quarters, which add up to $42.50. So one thing to mention is that you could have chosen different letters, but the main point is that one of the variables is expressed in terms of the other. So for example, I could have chosen, if I wanted to, I could have chosen, let's say, M for, or not M, because M is in the mx plus b. You could choose M if you want to, but I could have chosen D and A. I could have chosen Q and P. It doesn't really matter as long as you express one variable in terms of the other. So you have one variable isolated, and then the other is in the equation that you can manipulate to change the other variable. So let's start example 3 out here. Ariana has $42.50, so same amount of money, but this time we've changed things up a bit. We've added more than one type of currency. We have quarters and we have dimes. So we want to write a linear expression expressing the total amount of money in terms of the number of quarters and dimes. So what we have this time is we need to define our variables. So we're going to say we're going to let Q represent number of quarters. You could have chosen X, doesn't really matter. And we're going to let D represent dimes. And so we're going to write an equation to get the total amount of money based on quarters and dimes. So what we know for sure is that Ariana has $42.50. $42.50. So we are going to write that our $42.50 is equal to 0.25, so 25 cents here, times the number of quarters that she actually has, plus our dimes. Dimes is 10 cents, so that's 0.10 D. And so here we have an equation just showing that the total amount of money that she has, $42.50, is equal to the number of quarters multiplied by how much they're worth. They're 0.25, so a quarter of a dollar, plus the number of dimes multiplied by how much they're worth, so a tenth of a dollar, 0.10. So our next question, part B, we have to write an equation to express the number of quarters in terms of the number of dimes. So we want to isolate Q. We want to isolate Q in this case. So we're going to do our inverse operations to do that. We're going to get rid of the D from the Q side, and then we're going to divide by 0.25 to get rid of that from the Q as well. So we're trying to express the number of quarters in terms of the number of dimes. So basically we're isolating for Q. Isolate Q. And so we get 42.50 minus 0.10 D is equal to 0.25 Q plus 0.10 D minus 0.10 D. I had to do that to get rid of the 0.10 D. So that leaves me with 42.50 minus 0.10 D is equal to 0.25 Q. The 0.10 D is gone because we eliminated it from that side. Now we'll divide both sides by 0.25. Divide everything here by 0.25. And then we can go and clean it up by dividing every term there by 0.25. So the 0.25s here cancel out, and we get 42.50 divided by 0.25. That's 170. Then 0.1 divided by 0.25. That's minus 0.4 D. is equal to q.